Every planet in the solar system spins the same direction. Except one. Something broke it, and it's still spinning wrong, right now as you read this. Venus. You've seen it 1,000 times without knowing it. That impossibly bright star, hanging low after sunset, the first light in the evening sky. Ancient cultures worshipped it. Poets wrote about it. Almost nobody ever asks the one question that actually matters. Which way is it spinning? Here's why that question matters so much. Every planet in our solar system formed from the exact same swirling cloud of gas and dust 4.5 billion years ago. Gravity pulled that cloud into a flat, spinning disk, with a young sun collapsing at the center. Every planet that formed inside that disk inherited its motion, like leaves caught in the same whirlpool. Look down from above the sun's north pole, and the whole solar system should turn one direction, counterclockwise, without exception. Earth spins that way. Mars spins that way. Jupiter, Saturn, Neptune, same direction, every one of them, obediently following the spin they were born into. Uranus breaks the pattern too, but differently. It's tipped almost completely on its side, rolling around the sun like a ball instead of spinning upright like everything else. Astronomers think a violent collision caused that as well. But even Uranus still turns in the same basic direction as the rest of the solar system. Venus is the only planet that flips the actual direction of spin, not just the angle. Venus spin clockwise. Backward. Scientists call it retrograde rotation, and it breaks the rule the rest of the solar system doesn't break. Stand on the surface of Venus. If you could somehow survive 800-degree heat and pressure that would crush a submarine, and you'd watch something impossible. The sun would rise in the west. It would set in the east. Every instinct you have about which way morning comes from would be exactly backward. And it gets stranger from there. Venus takes 225 Earth days to orbit the sun. That's one Venus year. But it takes 243 Earth days just to spin once on its own axis. Do the math, and something breaks. A single day on Venus, sunrise to sunrise, lasts longer than its entire year. You could watch an entire orbit around the sun complete before you saw one full sunrise. So what is that to a planet? What takes a world spinning normally in the same direction as every neighbor around it and flips it into reverse? Scientists have chased this for decades. There's no single confirmed answer. There are suspects, and each one is unsettling in its own way. Suspect number 1, a collision. The early solar system wasn't calm. It was a demolition derby of planet-sized objects still finding their final orbits, still slamming into each other while the sun was young. One leading idea says a body roughly the size of Mars, or bigger, hit early Venus at exactly the wrong angle. Not a glancing scrape, a direct strike, violent enough to physically knock the planet's spin off balance, the way a hard enough shove can flip a spinning top upside down and leave it still turning, just in reverse. Suspect number 2 doesn't need an impact at all, and that's what makes it unsettling. It's happening inside Venus right now, silently underground. Deep beneath the surface, the planet's molten mantle and dense core move at different speeds, dragging against each other at the boundary between them. That friction, stretched across billions of years, can slowly torque a planet's entire rotation in a new direction. No collision required. Just time, pressure, and friction, doing what they do when nobody's watching. Suspect number 3 lies in the sky, not underground. Venus has the thickest atmosphere of any rocky planet in the solar system, 90 times the pressure of Earth's, made mostly of carbon dioxide, thick enough to bend light and crush machinery. That atmosphere doesn't sit still. It races around the entire planet in about 4 Earth days, 60 times faster than the solid ground spinning underneath it. When the sun heats that massive, fast-moving atmosphere unevenly, it generates enormous tidal forces, strong enough that once a planet's spin has already slowed to a crawl, they can deliver the final push in a full reverse. None of these suspects fully explains Venus by itself, and that might actually be the real answer. The leading theory today isn't one dramatic event. It's a sequence stretched across billions of years. First, a massive impact early in Venus's history, violent enough to knock its spin down to almost nothing, not necessarily reversing it instantly, just slowing it to a crawl. Then, over the billions of years that followed, that thick atmosphere and the sun's relentless heat took over, nudging the crawling spin the rest of the way into reverse and locking it there permanently. Violence first, then a billion-year-long finishing touch, written slowly by heat and atmosphere instead of impact. Think about what that actually means. The direction Venus spins today isn't just a fact about the present moment. It's a fossil, a permanent, readable record of a moment of extreme violence near the dawn of the solar system, still visible 4.5 billion years later, just by watching which direction the sun rises. And here's the part that should really stop you. Venus and Earth are almost twins, nearly the same size, nearly the same mass, formed from nearly the same material, in nearly the same region of the early solar system. One small difference in the angle, the timing, or the size of an ancient collision, and Earth could easily have ended up spinning backward instead of Venus. We don't know exactly how close that was, but it's close enough that scientists take the question seriously, and close enough that it should probably keep you up at night. It matters beyond just our solar system, too. When astronomers search for potentially habitable worlds orbiting other stars, they can't actually watch how those planets spin. They have to estimate it, using the same physics that supposedly shaped our own solar system in an orderly way. Venus is living proof that estimate can be wrong. A planet can start out completely ordinary on the same track as every world around it, and still end up almost unrecognizable because of one violent moment billions of years in its past. That's a hard thing to plan for when you're trying to figure out which planets, anywhere in the universe, might actually be normal. So the next time you spot that bright point of light hanging in the evening sky, remember what you're actually looking at. Not just a planet, a survivor. Something that took a hit so violent, it's still reversing that world's clock, one backward sunrise at a time, billions of years later. If Venus can carry the scars of its past written directly into its spin, imagine what else is hiding in plain sight across the rest of the solar system, waiting for someone to ask the right question. Follow for the next one, because this mystery isn't even close to the strangest thing still out there.